It's time to start a new unit on quadratic functions, and to do that I need to teach you some vocabulary so that you know what I'm talking about as we dig deeper into how to graph quadratic functions. My goal for you is that when you're done with this video, you're going to be able to identify key features of quadratic functions called parabolas, such as intercepts, line of symmetry, vertex, minimum maximums, and range. So as a reminder, a quadratic function is just the graph of an equation whose highest degree is 2. So here's one possible equation right there, f of x equals x squared. We don't have to use f of x. We can say y equals x squared. Both of those are interchangeable. It could have more terms, not just x squared. No matter what, it does have to have x to the power of 2 as its highest degree. So what do we do with all these? What do these look like? Well, the graph of a quadratic function is just a U-shaped curve that we call a parabola. Here's another parabola. As you can see, it still looks like a U. It's just shifted a little bit further from the origin. Sometimes it's much higher than your x-axis. And sometimes the parabola tips upside down like this one. Here's your next vocabulary word. The lowest point on the parabola that opens up, or the highest point on the parabola that opens down, is called the vertex. Now, the vertex is just basically the tip of the U for your parabola. When identifying the vertex, you always give the ordered pair of the location where your vertex is sitting. Where is the vertex for this parabola? Well, if you said 1, -2, you are correct. Here are our next two vocabulary words. If the vertex is at the bottom of the parabola, we call it a minimum, because that's as low as it can go. If the vertex is at the top of the parabola, we call it a maximum, because that's the highest that parabola can go. For the first one, the minimum is at a -2, and that's just a -2 at the y-line, where it hits the y-line. And then the other one, the maximum is at a 2, and again, this is where as tall as it gets on the y-line, right there. So is this a minimum or a maximum? Well, this one is a minimum because the vertex is at the bottom of the parabola. So this is the lowest it can go. And it looks like, what is it? Looks like the minimum is a -2. It sits right there where the y equals -2. The next two vocabulary words are domain and range. The domain for any function is the set of x values that you can put into the function equation. The domain for parabolas is all real numbers. If you look right here, my equation is x squared plus 4x plus 3, and I can put any number that's real in that equation and get something out for y. And so you see -3, -2, 1, 0, those are part of the domain, but it could go on 1, 2, 3, 4 million. That is your domain. Your range for any function is a set of y values that are created when you put numbers in for x and solve the equation. So when I put in the -3, -2, 1, and 0, out came the numbers there that are in red, 0, -2, 0, 3. So 0, -2, 0, 3, those are your range. Now, is the range all real numbers also? Well, not exactly for a parabola. The range for a parabola will not be all real numbers. It's easy to see the range just by looking at the graph. Here you can see that it is every y value from -2 and above. So see where your minimum is, sitting there at the -2. That's the lowest that parabola is going to go. But it's going to go on forever as it goes up. We show the range with an inequality. In this case, my y values are going to be greater than or equal to -2. So here's a parabola that is going upside down, and its vertex is the maximum. It's the highest it can go. What's the domain? All real numbers. What is the range? Well, the range, 2 is the highest it can go. That is as high as it can go, but it can go down forever. And so what would that inequality look like for the range? Well, it's just y is less than or equal to 2. What is the domain and range for this parabola? Pause for a minute, think about it, and then keep on going. Big surprise there. The domain is all real numbers. That wasn't really a surprise. The range looks like y is greater than or equal to -2 because that's the lowest it can go is the -2 on the y-line, but it keeps on going up and up and up forever. Here's our next vocabulary term, axis of symmetry. You can fold a parabola so that the two sides match exactly. This property is called symmetry. The fold or line that divides the parabola into two matching halves is called the axis of symmetry. And a lot of times you'll see the axis of symmetry shown as a dotted vertical line like this. Now every line has an equation. So do you remember what a vertical line equation starts with? Well, if you said x, you're right. The axis of symmetry for this parabola is x equals -2. Finding the axis of symmetry number is super easy. Just find the vertex, and we already know the vertex is right here. And so it's the x value of the vertex. If your vertex here is -2, 2, what's the x value? -2, bam. That's your equation, x equals -2. It's that simple. What is the axis of symmetry for this parabola? Well, if you said x equals 1, you are correct. Our next term is intercepts. We've got y-intercept and x-intercepts. The y-intercept is where the graph touches the y-axis. When I say the graph, I'm talking about the parabola. So where does it hit the y-axis? The x-intercepts are where the graph touches the x-axis. So in this case, the y-intercept is at 3. And if you wanted to write it as an ordered pair, we would just say 0, 3. This parabola has two x-intercepts. They are at -3 and -1. And again, if you wanted to write the ordered pairs, it'd be -3, 0 and -1, 0. Parabolas are always going to either have 2, 1, or no x-intercepts. So I've given you the 3 examples here of what that would look like. So what is the y-intercept for this graph? Where does it hit the y-line? If you said -2, you are correct. What are the x-intercepts for this graph? Remember, that's here and here. So where does the parabola hit the x-axis? Well, if you said -3 and +5, you are correct. Other names for x-intercepts are roots, zeros, and solutions. We can use those interchangeably. But what I'm going to focus on for the rest of this video is the term zeros. The term zeros comes from when we factor a quadratic and solve for 0. So I'm hoping that you have already done factoring of trinomials before this video. Our first step in solving is to take away the f of x or the y and put a 0. And then our next step is to factor that trinomial into two binomials. So this was pretty simple. Since my a value is 1, I can just find the factors of 3 that add up to be 4. So what numbers multiply to be 3 to add up to 4? Well, if you said +3 and +1, you are correct. And so here are my two binomials. What makes each of those binomials equal 0? In other words, if I said x plus 3 equals 0, what would x be? X would be -3. And if I said x plus 1 equals 0, what would x be? X would be -1. So my solutions are -3 and -1. Oh, where did that parabola go through the x-axis? At the -3 and the -1. Cool. What are the zeros for this quadratic function? If you said -5 and -1, you are correct. But let's go ahead and prove that -5 and -1 are the zeros by solving this equation. So as you look at it, what would your first step be? Well, mine would be to factor out a 2 out of everything. Just divide them all by 2. Why would I do that? Well, because what's left over is really easy to factor because, again, my a value is just a 1. And I'm like, okay, the factors of 5 that add to be 6. What multiplies the 5 to add to be 6? 1 and 5. And so here we go. What value of x would make that 0? Or you could even ask, what's the opposite of +5? -5. What's the opposite of +1? -1. So my solutions are -5 and -1. Haha! I just proved it by using the equation, solving the equation. Sometimes you're going to be given an equation and not a graph, and you will have to do this to find the x-intercepts or the zeros. All right, I've given you all the terminology I can right now. Go practice because practice is going to make you better at remembering these names. Go have some fun.